Hello and welcome to the Basic Statistics and R Windows 7 video tutorial for Econ 4650. The objectives of this video tutorial are that you'll be able to install R, identify and change the current working directory, calculate statistics using R, create a scatter plot, and upload your output to Canvas. There are two texts available for this course. Either one works. There is the normal or regular text of Studentmun's Using Econometrics, A Practical Guide, 6th edition. And there's also the short or custom text, which is available in the bookstore. And page references in the videos will be out of the short or custom text. So the first step is going to be to download and install R. So you're going to want to go to cran.us.r-project.org, and you're going to want to go down to download R for Windows and select the base distribution there and download R for Windows. Once the download is complete, you can go ahead and select the exe file that it downloaded. You're going to get a security warning, and you can go ahead and select Run. And then you can select the setup language that you are comfortable to use during installation. From here, it'll open up the installation wizard, and the default installation location will work fine. It's going to ask you which components of the software you want to install. For our purposes in this class, the 32-bit user installation will work fine, so go ahead and just keep the default selection that it has there. And you do not need to customize any startup options, and it'll create some shortcuts, and that's fine. From here, it will install the files. Having installed R, we're going to go ahead and run the program, and here you'll see we have a window, the R console, as well as a prompt and a blinking cursor there. So the first thing we're going to do is identify where the current working directory of R is. The current working directory is important because that's where R goes and looks for any data which you wish to import. It's also where it will go and save any variables or objects that you create during your R session. So we're going to say get wd, open paren, close paren, and it'll return the current working directory it's using. Yours should look very similar to this by default, with the exception of your username in the middle there instead of Martin. So if you'd like to change the current working directory, which is helpful if you have a file saved in a different folder, you're going to go ahead and say set wd, open paren, quotation mark, and then type in the directory you want to change it to. And you want to end it with quotation marks and paren, no need for a trailing forward slash, and press enter. And then if you want to confirm that the change has been made, you can say get wd with open and close paren once again, and it'll show you the new current working directory. Two things to note. One, in Windows, R is using forward slashes instead of the traditional backslashes to demarcate folders, so go ahead and be aware of that when you're typing in these directories. Also, commands in R are case sensitive, so if you type in get wd with a capital G, it will give you an error. So the next thing we're going to want to do is go ahead and adjust the number of digits which R is going to show you when it gives you an output. This is so that it will better match the text guide that's available online. So you're going to say options digits equal to 4, and now that has changed. So now we're ready to execute some basic commands in R. So R can be used as a simple calculator. For example, 2 plus 2. R will return the answer of 4. 2 times 3. R will return the answer there. 2 raised to the third power. You can do that with the caret key of 8. You could find the natural log with R. So you could say log of 2.71821, and it should return 1. You can nest arguments within commands, so you can say the log of 1 to the exponential. It'll return 1 there. So those are some examples of basic commands that you can do in R. Next, we're going to enter some data from the book and save it as a vector in R called x. So the data is from a random sample of the height of US women, and it is found on page 9 of the text. So in R we can type capital X with the less than sign and a dash, and lowercase c, which stands for combine or concatenate. We're going to combine the following numbers into one vector in R. So the numbers are 61, 63.5, 66, 68.5, and 71. And in R, you can see your workspace image by typing ls, open paren, close paren. And in the workspace image, what you're seeing here is that R has one piece of data, this vector called x. As an aside, you can note that the workspace image is typically, under default conditions, saved in the working directory that you exit R in. So keep that in mind if you're going to change working directories during your session. So R knows that there's something called x here. If you type x, you get those numbers back, and we can use R to manipulate these numbers. So the textbook states that the mean of these data is known to be 66 inches with a known standard deviation of 2.5 inches. So let's use R to calculate the standardized z values from this data. So z is equal to x minus the mean of 66 divided by the standard deviation of 2.5. And if you type in z, you'll see the results of the standardized z-scores there. You can also use R to calculate the mean. So mean of x, the variance as VAR of x, and the standard deviation SD of x. Now, let's assume that the heights are distributed according to the normal distribution with that mean of 66 inches and standard deviation of 2.5. We can have R randomly sample from this distribution. So let's create a sample of 100 draws. We're going to call it x100, and we're going to use the command rnorm to give us 100 draws from that random distribution with a mean of 66 and a standard deviation of 2.5. So what this is telling R is grab 100 numbers from a random normal distribution that it creates with a mean of 66 and a standard deviation of 2.5. Technically it's pseudo-random because R will actually use the current date and time when you do this to seed the random number generator. So if your numbers are different here than what show up in the text, no need to worry, and we'll talk about that again soon. So we can find the mean of this draw. We can find the standard deviation of this draw. And we can have R create a simple histogram for what these data look like. HIST x100, and R will open up the histogram there in the window. And so now we're going to seed the random normal distribution so that we can get the same results. This is helpful if you're trying to do something that is completely reproducible. So we say set seed set.set.seed of 100. That's the seed value. And we're going to define a new draw as x100a. Once again with our norm, and it's going to be a draw of 100, and the distribution it's pulling from has a mean of 66 and a standard deviation equal to 2.5. And once again we can find the mean of this, and your mean should match that, as well as the standard deviation of this draw. And once again your standard deviation should match that. And now we'll create a histogram of this draw as such, and we can determine the quantiles of the data using the quantile command. Which will show you by default quantiles at the standard probabilities of 0%, 25%, 50%, 75%, and 100%. So in this case we can see that the median of this random sample is 65.85. So now we're going to go ahead and look at the distribution of a draw from a much larger sample of size 20,000, again from a standard normal distribution. So let's set a new seed, set.seed 666, and we're going to call this draw zdraw. And in the rnorm command we're going to ask for the draw of size 20,000. And we're going to give it a new mean and a standard deviation of 1. And so now we can find the mean of zdraw, which should be the same. You should have the same as what I have here, 0.007248. And so now we're going to once again grab the quantiles, but we're going to request certain percentiles for the probabilities. So we're going to say quantile of zdraw, and for the probabilities, once again we're going to use that combine function of 0.01, 0.05, 0.95, and 0.99. Make sure you close that off. And here R will return the requested percentiles. And next we're going to do a density plot of the large draw. So we're going to say plot density zdraw. And here we have simply demonstrated using the setSeed command and some essential basic functions. Okay, so having learned how to type in data and create vectors in R, now we're going to learn a different way to get data in. So we're going to go ahead and go to pearsonhighered.com/studentmund. And what we're going to do is we're going to go in and grab the data set from our introductory chapter, which is chapter 17 of the book, and grab it in Excel format. And this is from the table in the chapter that's about home prices. I'm going to go ahead and open it in Excel. Any other spreadsheet program should work. And what I'm going to do is convert this data file to a CSV file, because that is what R can handle. So I'm going to go ahead and find a place to save it. that works for you. And I'm going to save it as a CSV file, and I'm going to say I'm going to call it stats17, and save it there. It's a CSV file. That's great. And I'm going to get out of there. You can kind of look at the data here, so kind of know what you're getting into. And I don't know what it wants me to, whatever. Alright, I'm going to get out of that. Ignore it. So now we're going to go ahead and pull up R again, see if I can get it working. And we're going to go ahead and read in stats17.csv into our R data workspace, right? So let's go ahead and our current directory is not going to work because the file is not saved in this folder. I have to change to a different folder, so I'm going to change my working directory to the folder I want. Just like we showed last time. And I'm going to type in dir, open and close paren, and it's going to show me what's in there. There's my file. That's what I want, stats17.csv. So I'm going to have our read that in. So I'm going to call it data17, and I'm going to have R say read.csv, and I'm going to tell it the name of the file in quotes that I want it read in, so stats17. .csv, and I'm going to tell it that the first row is a header, so that it doesn't just create new headers and treat the first row as data. So that's what we're going to do. And now if I type in data17, R has gone ahead and brought in the CSV file as a data frame, which is basically R's way of storing tables. And so when I typed in the name of it there, you saw that it displayed the whole thing. If you're working with a data set that's way too big, or like R will still try and show you the whole thing. So let's say that this data set was really long, then we could just say head of data17, and then it would just show you the first few rows. Or if you wanted to say tail of data17, it'll show you the last few rows, and it'll show you the columns there too. Another thing I want to show you real quick is that you can ask R for specific like locations or numbers within these data frames. So if you said data17 and then square brackets, and let's say you wanted the price of the 20th house down, so you would say quote 20 for the 20th row, and you want the entry from column price, and then that'll show you an error because I closed it with a paren instead of with a square bracket. So close it with a square bracket, and it'll show you that is the price of the 20th row house there. So that's just kind of something to keep in mind. You can use R to specifically get that information. Another way to get the same thing would be to say data $, specify that you want the price row, and then do the square bracket 20, and it'll show you an error. And I'm trying to remember why. Oh, it's because I didn't type in data17. So you want data17, not data, because it doesn't know what that is. The name of the object is data17, $price, bracket 20 in bracket, and it'll show you there that's the same price, right? So there's 3 ways to get what you want if you were looking for a specific thing. So now let's move ahead and look at summary statistics for the whole data frame. So if you typed in summary data17, then that's great. it'll give you data summaries for each of the columns there, which is kind of cool. And then you can get a scatter plot of the data pretty easily. So you would just say plot data 17 $, square foot SQFT. So that's what we're going to have on the x-axis, and on the y-axis we're going to have data $ price. So again, we're saying, oops, I made another error here. Don't say plor, say plot. So we're saying that we want R to go out and specifically grab the columns square foot and price from the data 17 data frame, and then plot it, and it will, and it's right there. So you can see that that worked out great. Another way to do this is you can access the variable names or labels from a data frame by attaching the data frame, right? So you would say attach data 17, and then that would go ahead and let R know that when you say something like plot square foot comma price, now R knows what you're talking about. It says, okay, you've got this data frame attached, so when you ask for square foot, we know you're looking for a column name within that data frame that's attached. So you got to be careful though. Leaving things attached in R is not very good practice. So we'll detach that in a second. You can get the correlation of square foot and price, which is pretty great, pretty easily. So it's there, which is, you can kind of judge that from the scatter plot. That makes sense. It's a positive correlation, great. And basically we're done. So we want to detach the label. Well, we want to detach that data frame because we no longer need those labels. So we're going to say detach data 17, and now now it's no longer attached, which is helpful. So let's check again what R has in its memory or in the workspace image by typing ls. Okay, and it's got all this stuff, right? I want to remind you real quick. So there are two kind of things at play here, right? There's the workspace image, which we just checked by typing in ls, and then there's the current working directory, right? So the relationship between those is that the current working directory is where R is going to go look when you're bringing in files, and when you exit the session, that's where it's going to save your workspace image. Your workspace image is what you're looking at right now. It's the place where all of the objects and vectors and data frames and things like that that you've brought in currently exist. So let's go ahead and just clear it out, right? Just blow it all away. So let's remove it. Rm list equals, let's see, ls close paren and another close paren, and now it's all gone, right? Boom. It says character 0, so there's nothing there. And so that's basically the end of that little part. The next thing we want to do is go ahead and access a table from the internet directly. Okay, so if you can get the information in .csv format, you can skip that step of pulling it into Excel and saving it as a CSV and changing the working directory and all this stuff, right? So this is how you do that. You use the same command, read CSV. So you say data, you say read.csv, and then you give it the web address where you want to find the data. So in this case, and you put it in quotes, it's going to be http://content.csbs.utah.edu/squiggly fowls, our fearless leader, /econ 4650 /data /stats 17.csv. Pay attention to the caps in this line. If we don't get it right, it'll spit back an error, which it might anyways. Let's see. Oh, and let's go ahead and tell it that, again, the first row is a header. So header equals T for true. and it looks like it worked. It didn't give me an error. This is excellent. So we can pull it in, and boom, there's our data again. How great is that? So that that essentially represents the skills that you should need to complete the first assignment, and that's about it. One last thing that I'd like to go over is getting your R output uploaded into Canvas. So one way to do it would be to take a screenshot of what you had and upload that. Another way would be to copy the images and text into some sort of Word or similar document and save it as a PDF. So that's what I'm going to do here. So let's say you had some data that you wanted to take out of R, some mean data, and you have a plot here. So you could just grab this, copy it with Control C, go in and Control V and dump it into a Word document, just copy and paste, and then you can go in and grab the plot too if you copy it as a bitmap, and paste that as a bitmap. Then you've got your R output there, and then if you go ahead and save this as a PDF file, then it'll save it as a PDF, and then when you go into Canvas, you can go into assignments and find the assignment, and then it's not unlocked right now, but when this is unlocked, you'll be able to upload the file here. So thank you. Moving on from here, Assignment 1 is available in Canvas in modules under Module 1 Statistics Review or the Assignments button on the left sidebar. The first chapter of the custom text, which is equivalent to Chapter 17 of the regular text called Statistical Principles, is also available under that first module if needed. Further chapters will not be available, so please purchase one of the books. And later modules may not differentiate between Windows 7 and Mac OS X operating systems. So just so you know, there will probably only be one video. And if there's any differences between Windows and Mac that come up, we will make separate videos as we need to. Thank you.